Hello, this is the presentation of Team 4 Web App Smart Habitat Finder. I am Akshata Kulkarni.
I am Anuj Kapoor.
I am Kaumudi Kusbarga.
I am Rakshit Modi.
Hi, I'm Shloka Pandya. So yes, welcome to our paper presentation, and I'll be describing the problem statement. So for Smart Habitat Finder, so let's say a person wants to travel or relocate. A person wants to travel or relocate to another city or community, then and they want to know if a city is sustainable or habitable for the travel purpose. So based on his own preferences like environment and crime. So in order to make this decision, they will have to do a lot of research, and that research is quite time consuming. By like they'll have to find all the valid and accurate sources for data aggregation, and then analyze all the data based on their city preferences. And this process could be very cumbersome. So in order to solve this use case, we have built a user-friendly web application that calculates a habitable index for cities based on the user preference, which we have set as environment and crime for this application. And it also provides customized insights with details on the sub-factors, which are the sub-factors which we considered are in environment, we have considered air quality, precipitation, UV, and heat index. While in crime, we have considered three major categories of crime, which are moderate, critical, and serious crime. Therefore, by making this web application, it is a step towards making smarter decisions in relocation, travel, and policy making. So this app mainly solves all the pain points of relocation. So for explanation of the high-level design, I'll hand it over to Akshita.
Thank you, Shloka. So in this web application, here we will, there are three web pages basically. One is homepage, results, and detailed page. This app will provide a customized user preference, customized habitable index based on the user preferences. So in homepage, there is a drop-down list where user can select a city, or they can also choose any option as any. And there is a slider which will set either they have preference more for environment or more for the crime, like less crime in the city or community, and more preference to the environmental factors, or less preference to the environmental factors and more preference to having less crime in the city. And user can also set the priority for environmental factors such as heat factors, or UV index, or precipitation and flooding index. And when user clicks on find the city, there they will be shown top 5 communities in the city, top 5 communities. And when user clicks on view detailed stats, they will be redirected to the details page where details of every sub-factor will be mentioned. And all of this data is fetched from the by querying on the ontology. And now I will hand it over to Anuj to explain the ontology.
Right. Thank you, Akshata. Yeah, for our ontology, we have basically clubbed together multiple factors, one of them being crime, the other being environment, and we are linking them together using geographic type. Geographic type is basically a combination of the main class of city, community, and county. County is the bigger area, then followed by city, and then community being the actual areas within the city. We have also linked this together with the geonames ontology that is already existing. It's a big open source ontology, and thus we are using it to equalize it. We have multiple features, and just Rakshit can go back to the ontology. We'll just see the properties and data properties.
Yeah.
So for object properties, we have has category, has crime, and is located in. These are the three new properties that we have, major properties that we have introduced. Has category links basic crime class, a crime object, to the category of whatever the crime was. Has crime is linking a community to the crime object, and is located is a transitive property that takes from one geographic type to another geographic type based on where it is located. We have also added some data properties. Data properties are for each of the environmental indices. We have also added some normalized properties that are all in range from 1 to 10, and some other properties such as name in ID and crime indexes. Yeah, that's all that we have added to our ontology. Now let's see the GraphDB resources. So here, if we go to the query, we can see this is the query that is linking together a feature to all of the details that we have added on our system from the Smart Habitat. So a geotags of Chicago is linked to the community Greenwood with the critical crime index, the serious crime index, the moderate crime index, and so on. If we just go to Chicago now, we'll see the Chicago is linked using our same as to the geonames ontology objects. And going on to that, we'll be able to see more details about that city.
Just give me a second.
Yeah, no worries.
Yeah.
Yeah, so this fetches up all the details about the city of Chicago. That's how we are linking. We can also similarly query on our graph DB over using geonames. That's something we have used in the query as just going to geonames features. And then this is our second major query that we are using to fetch the details about all the about a given community. Yeah, from this, I think we can just now go over to our index calculation part. Over to you, Kamadi.
So for Rakshal, can you go back to the paper? So for the index calculation, we have two main factors, that is environment and crime. And the very first formula we see is normalization of each of the environmental factors, which include air quality, heat metric, precipitation, and UV radiation. So once these values are normalized, we then use user-given preferences to weigh them and aggregate them, which is shown by the formula below. If you scroll a little bit, yes. And this gives us the environmental subindex, which is further normalized to give us environmental index. And then we calculate the crime index, where we have three types of crimes: critical, serious, and moderate. For these, we have given our own weights, which are Fibonacci, which follow the Fibonacci sequence. Moderate is given a weight of 3, serious 5, and critical 8. So the Fibonacci weights are applied to reflect the escalating impact of crime categories in a balanced but intuitive way. And the crime indices for different categories are calculated based on the number of those types of crimes committed. And those are first normalized and then weighted with Fibonacci weights and aggregated. And then they are further normalized. And finally, we combine both of the indices, that is environmental index and crime index, based on user preference as a percentage, which will give us the final habitability index of every community. Next will be the demo of the whole application. I will hand it over to Rakshal.
Yeah, thank you, Kamalin. So now let's begin with the queries, what Anu just mentioned. So we have used Spring Boot for this application for writing backend SQL queries, SparkQL queries. So this is a community. This is queries for fetching the community. Let me begin with the starting. So this critical query community is used for getting critical crimes with the critical, which are critical, the moderate crimes and the serious crimes, and the critical all indices are the is the query for getting all the crime indices mixed of serious, moderate, and critical crime. So this is further normalized as what Kamuli mentioned again. So this is the final index after the complete normalization. Now we are again adding this query to the database for making it for preparing the database more efficient according to our priorities. So now these are the queries used for calculating air quality, heat index, precipitation, and UV rays, which is quite similar to the what we calculate for serious, moderate, and critical crime. Now, yeah, this is the query fetch index by the community. So whatever preference we will put into the data, whatever the preference the user puts, according to those preferences, the top five communities will be fetched from this fetched from the GraphQL and database GraphDB database. So yeah, and this is the get community details. Like if we click on like what Akshata mentioned for getting the details of each community, we will run this query for getting the details of each community details. And this is connected using GraphDB database, which is hosted on Azure platform. And this connection is made using SparkQL config. Now let me show the demo of our application. So yeah, so this is our application. Looks what it looks like. It's a home page, and this is you can see it's deployed on Azure Static website. So now as a user, I want to go to Chicago, and my preference is like there should be strong preference to less crime, and my precipitation. I have a huge preference about precipitation, then air quality, then I just like find my location. My request is being processed, and I'm getting the top five communities. Based on the top five communities, I think that Edison Park is a good score, so I would go to the Edison Park. Now I'm clicking the details. I'll get the exact details about Edison crime. Where is the county location, and what is the heat index, air quality, and so on. So about what are the crime index we want. Similarly, if we go for I want the environment with a better crime index, and I want to go to Los Angeles, where UV radiation is most important for me. Then comes heat metrics. And I again click on the to get the preference. So I get like harbor in the LA is the most important thing, the most crucial thing. When I click on this thing, I get LA, Los Angeles County with score as 6.616 and environmental metrics and the crime metrics. Again, if we choose any and preferences to be neutral, then we can get the preferences like this. We get Edison Park to be the most ideal situation where crime is also less and environment is also pretty much good. We get this kind of information about Edison crime. Now, all these applications are hosted on Azure Cloud. So this is our front-end application where it is hosted over it. And you can see the purple mushroom static.net, and this is our website name. While the backend is hosted on Azure using web apps where it's up and running. So you can see this thing also. While GraphDB is hosted or using virtual machine, and this is a public IP for the GraphDB, which you can see here where Anuj also already showed the query. Now I hand it over to Anuj for further details. Thank you.
Thank you. Yeah, so let's just talk about our individual contributions here. For GraphDB and linking data, we had divided our tasks into different data sets. Environment was taken care of mapping by Shloka. Crimes was divided further into two based on the cities, LA and Chicago, from Akshata and Comedy. Community and city mapping was done by Rakshal, and then the crime categories mapping was done by me. The overall combining of all the data sets together into GraphDB and populating them was also done by me. Aligning the ontology I added some more details to the ontology, such as ID, and made some changes and linking it to the geonames one. For the backend, the initial setup was taken care of by Rakshal. There were some multiple issues seen by as course error, and Rakshal also implemented some industrial norms like logging, the hosting for all backend, frontend, and GraphDB, and then the implementing the CI/CD pipeline, as well as the GitHub readmes was done by Rakshal. APIs for update index was taken care of by me for crime and Akshata for environment. Fetch community details API was written by Komadi and Shloka. Fetch to see more of the details about each community was done by me and Komadi. For the front end, initial setup was done by Akshata as well as the homepage. Then results page was done by Shloka. Details page was done by Rakshal. Then API linking of front end to the back end was again done, divided into the whole team. Homepage was taken care of by Rakshal. Results to show the top five communities was done by me and Komadi. And then show the details of each community was also done by me and Komadi. We all came up with the scoring index together as a team over a call. For user reviews for the project, it was handled by Rakshal and Komadi. And then for paper writing, we divided it up into parts segments as well. Scoring algorithm was written by Komadi. The implementation details and then linking the part about linking ontology to geonames was written by me. For evaluation and discussion of the project was done by Rakshal. Ontology updates and queries were mentioned by Shloka. And future challenges and future work was done by Akshata. Yeah, that's all.
That's all.
Thank you.
Thank you.
Thank you.